Hello everyone, my name is Alex Scrocky. I am a first year PhD student and today I'll be running a video on how to do an exploratory factor analysis, otherwise known as an EFA. Through this video, I hope to teach you how to run an EFA as well as work through and produce the final products being a R script and an APA write-up. The R script will be completed as we move through our video, and then I will show an example APA write-up at the end to help you with that portion of a final product. Before diving into the R script, I'd like to briefly go over what an EFA is. So an EFA is used to explore the underlying structure of observed variables. And in this light, it describes the data and summarizes them into factors. These factors are thought to cause the variables as we are exploring the ways in which different variables are loaded. And it describes the common variance or variance that is overlapping between items. And to give you a little bit of context for the data that we'll be working with, it's going to have 109 cases. Researchers were developing a new self-report questionnaire on the SAAS scale as part of a larger battery of other psychological tests measuring aspects of social anxiety and body image. And they were interested in examining the latent structure of the 9 tests. So for us today, as we're doing an EFA, a important research question to have is the second one, how many factors best fit the data? And then we can also look at those correlation patterns to see if there's factors accounting for different patterns among the 9 scores, the scores on the 9 tests. If you knew the data set a little bit better or had access to supplemental material for the data, such as measures or items themselves, and you knew about the theory supporting social anxiety scales, you could also see if this matched expected theory based on how those factors loaded. We won't get into this one today, but it is something that I wanted to cue y'all's attention towards. So as I work through, I'm going to have this R script open, my R notes basically that has a script and some notes on it, and then I'll also be working through it in R. So I'm going to go ahead and split my screen here. So that way it's a little bit easier for me to work through both. And let me just adjust some things so it's a little bit easier to read on the RStudio side. So make that smaller. Bring this guy over. Okay, awesome. So the first thing you want to do is load that data in. You can load it different ways, but I like to find the file, copy the file location in, and open the read table function. And as you can see, we have our 9 here and 109. So everything's looking good and accounted for. Our first steps are all going to be about assumptions and diagnostics for EFA. And as I go through the script, I like to make notes of what I'm doing. And that way, when I come back to my script, I understand how everything is going or how to work through things. So observed variables are linearly related with product moment correlation, and that's an assumption of EFA. So when we go down to our correlations and we run them, we're going to do a product moment, but we'll also run a Spearman correlation. So if we're doing product moment, when there's 5 or more, you can check the linear assumptions using scatter plots. So I'm going to go ahead and copy in this note for myself that we're going to examine it graphically before doing anything further. And we're going to need our car function, our car package. And if you don't have that installed, all you're going to type in is install dot packages, and then go ahead and add that package name in. But since I already have it installed, I'm not going to go ahead and install it twice. And then the second line of script is how you make the scatter plot. And again, when I loaded in my data, I named it EFA data. So anytime you see EFA data, that is the data set we are working in. If you name it something different, you're going to need to change it to match. And so once you have that loaded, it will go ahead and populate a chart. And this is a scatter plot chart. And what we are looking for is any instances where linear assumption is violated. And so anything that kind of looks not straight. So here we have some curved trends. And so we want to look at this a little bit further. So this is between SPS and SPAS. So in order to do that, we're going to look at the association between those two. So I'm going to go ahead and just copy in those notes and then go ahead and copy in script and Control Enter. Well, let's go ahead and take a look. See if we did something wrong. Unexpected error. I do have another script. Let me see. Oh, could be that it wasn't doing the, there we go. So it looks like this needed to be in green for some reason, or when I copied it over, it didn't copy over correctly. So lessons learned. Okay, so moving on. So we see that this has a curved line to it. It's not really diagonal. The chocolate chips are not all diagonal, as our professor would say. So with that, we are going to go ahead and do a transformation to rank these two variables and hope to linearize the bivariate association, which I have here. So we're going to transform this data. So let me see if this doesn't work, I'll have to be back and forth within two R scripts. So just give me a second. Also, I need to put in my notes. So hashtag, put that in. Okay. Yeah, so there we go. I don't know what happened before, but we're doing good. So here we see a diagonal trend among these points, very evenly distributed. So that rank order, that rank was exactly what we needed to do. And so at this point, now that we've kind of looked at our data a little bit, you can, go ahead and do, so you could do missing data, outliers, normality, all of the data screening that you want to do. But for purposes of this, my goal is to teach you EFA, so I'm not going to go over that. But I will say one thing we do need to know is just a little bit about our data before we move forward. So we're going to go ahead and do a summary, and we're going to type in EFA data. And when we do that, when you type too fast, it is case sensitive, so you need to go ahead and type a little slower. And there we go. We can look at our data a little bit, and we do see that we have one NA here underneath the 8-ball variable. So at this next step, when we do our correlations, we're going to keep that in mind, and we'll use the, as noted over here, the complete observation function to account for that variable. Now we're going to do correlations two different ways because we want to do the default, and then we're also going to do Spearman to see if there's any difference. So when we go ahead, we'll go ahead and do the default first. Just go ahead and copy in my notes. I'm going to change this to default. This is actually product moment, so we'll call it that. Okay. I don't know why I was putting parentheses or whatever. So for the default one, you don't need to state anything in particular. So you're just going to do the correlation and use complete observation. And there we go. And I'm just going to go ahead and run the Spearman, and then we can look at how these two vary real quick. It's just a little bit easier to see, I think. And so we're going to do that again, but we are going to add that method in and do Spearman. Okay, so let's just look at SPAS versus SPS. And so here, the correlation using the product moment is 0.455, and the one using Spearman is 0.562. So there's a little bit of difference here. and I chose to use Spearman correlations in my report. And just to give you an idea, you can easily make a correlation table. So this was the output from our R script, and I went ahead and just reformatted it and got a nice table that's easy to read. And here we can, begin to look at the correlation between different variables and seeing if there's any relation as identified in our research question 1. But we're not going to do that. We're going to keep going. And so with that, we are done with our assumptions and diagnostics. And so we're going to go ahead and move into our next step, which is going to be specification of the common factor model. And like I said, this first section might have taken a little longer if you did take time to do missing data, outliers, and normality. But for us, we're going to move right past that. So a major goal of EFA is to determine the number of common factors, explaining patterns and observed variables. And so we're going to estimate the model using maximum likelihood, as that is the standard model estimation practice for EFAs. So we're going to go ahead and run a 2-factor model. And I used the book by David Flora for my practice data set and guidelines. And so in the book, he goes over a formula to get in the number of factors, and the factor number was 2. So that's what we're going to go off of. It's very complex, and he goes over, all of this stuff of how to get it. He goes from that to m equals 2. So we're just going to go with it. And so this first line of script is to go ahead and run that factor estimation, and this ML is for maximum likelihood. And then this 2F mod is to go ahead and get that output. So we're going to go Control Enter on that. And we're I'm going to interpret this a little bit, but we're going to come back to this at the end. So here we have our factor loadings here. And so you can see that ML1 is factor loading 1, ML2 is factor loading 2. And then H2, as noted in my notes over here, is the commonality estimates, and U2 is the uniqueness estimates. And so that's all that information right here. And then we can also see that there's a correlation of 0.62, and that the RMSEA is 1.36. And that's kind of all the information. Oh, and the RMSR is 0.05. That's all kind of all the information that we're going to get from this output that we need. And so we're going to go ahead and proceed. And if you wanted to run the residuals for this, go ahead and put a note in there. All you would do is 2F mod, I think it's $sign and residual, and then Control Enter, and there are the residuals. So you can also report this if you needed to, but for us, we're just going to go ahead and keep plugging. And so that leads us to our next step, which is optimal number of common factors. And so with this, we're going to see it in a few different ways. We're first going to run a scree plot. A scree plot plots the eigenvalues of both the unreduced and reduced correlation matrix, and we're going to be looking for a big drop-off on our graph. And so we're going to first do this with a 1 model factor estimated with unweighted least squares. And so we're going to run the scree plot. And again, you don't have to have all these notes in here. I just think it's a little bit easier when you're coming back to it and you're asking yourself, now what did I do? It's just a little bit easier to see. So when we run that, we can see kind of a big drop off right about here. And you can run this again with a little bit more information, noting the we're just going to go another way. We do a scree plot. And in this way, we're going to, specify that it is a one-factor mod. We're going to put our EFA one factor and go ahead and add some titles for our X and Y axis. And as you can see, it pretty much looks the same as the one prior. So those are two different ways to do that scree plot. Now, if you don't trust your eyeballs to look at this graph and get the number, you can run or evaluate using the Kaiser criterion. Now, it is noted that the Kaiser criterion is not well used anymore, as it also is just kind of outdated, and it overestimates the number of factors needed. But we can run that with the maximum likelihood, and we'll use the old Kaiser and the new Kaiser at 0.7 and 1.0. And when we run those, it's going to say number of factors is, with the parallel analysis, it's 2, but with the Kaiser, it's 1. So this was that parallel analysis, and then these are the Kaiser ones. So moving from that, we're going to do our last step in this section, which is going to be our parallel analysis. So go ahead and type that in. And a parallel analysis is conducted for EFAs and principal components. But in order to suppress the principal component, we're going to use the FA argument. So we're going to go ahead and copy this in here. And with that, it's going to suggest the number of factors like it did before is 2. And we also get a nice little graph here. And what we're looking for is where that blue line, the actual data, intersects with those simulated or resampled data, or the red line. And it's right about here or right here. So you can also simplify or specify quartile ranges for the eigenvalues if you are interested in what that looks like. The graph doesn't look very different from the one we just pulled, but we'll go ahead and do it. And that will pull out this. So there's a little bit more separation in those simulated and resampled. And these are errors that we've gotten, but we don't need to worry about them. And so lastly, we're going to look at model fit. And so we're going to see how well our two factors are, our two estimated our model. We're going to see how well our factors, our two-factor model fits. So we're going to go ahead and run 2 lines of code. And this first line is getting basically just a data file for the final model. And this oblium is kind of fun to say, but hard to spell, is a kind of a descendant, if you will, or related to oblique rotation, which means that factors are allowed to correlate with each other because we are doing a factor exploratory factor analysis. We want to see if there are any overlap item sets. And so we're going to go ahead and run that. And then to get our CFI, we're going to run one more line of code. And that will give us our CFI. And, we're going to have to probably copy this over again because it is not liking that it's not in green. I don't understand it, but sometimes it's like that. So let's add another there. Okay, so somehow it's in green and it's going to like it. And there we go. And CFI is 0.94. So we can take all of this script and we can interpret it in the form of a APA report. And so here we have that. So I'm going to go over this real quick. So I just like it to have this for my own reference. So this is kind of a little bit about the data set, about the study, and then those 2 research questions. Moving on to that, we have our methods. So I go over data screening. I went ahead and made a correlation table, noting that it's the Spearman correlations. And then I kind of went into a little bit about simple solutions and parallel analysis. And so I have our scree plot and our parallel analysis there. And then I said that two-factor model was achieved. I reported the RE Messier, the CFI, and the factor 1 and 2. If I had information on these items or particular questions, I would go ahead and insert some of them as an example to show the differences between these two factors, but I don't, so my results is pretty small. I also noted here that, and this would probably go in future directions, but I just put it here as a note that some of my values are negative. We saw it here and we saw it again at that correlation table. And so I'd want to look further at the data and see if there's anything that needs to be reverse coded or is just maybe a bad item. So that way we'd load a little bit differently. One thing to note, I did this is my third time making the video because I forgot to record and then made some mistakes. But I have one problem that I haven't been able to solve is that there comes a certain point where I get different factor loadings. And so this last time I got the same numbers as I've gotten before, but sometimes I get a little bit different loadings, and those are not in here. But if I ran, let's just compare. Maybe when my professor watches this video back, he'll be able to be like, oh, I know what you did. So there's one set, and maybe they will be the same. Nope. So there's one set, and they're a little bit different than this other set. And for the life of me, I cannot figure out why. So this is 0.71 and this is 0.66, and my correlations remain the same each time. So I'm not so sure, not these correlations, but my overall correlation chart. So not sure what's happening there. Just wanted to note that before closing out the video. Everything that I covered today will be linked in the YouTube file, hopefully, and I hope this helps. Thanks, y'all.